Jai Hind. My name is Babita. I am assistant professor in MCA department at Ajay Kumar Garg Engineering College, Ghaziabad. So today we are coming with a new lecture in the series of problem solving using C, and this subject is for MCA students, and the code is BMC 102. So basically, in the last class, I discussed with you about the memory allocation. So in that lecture, we will discuss static type of memory allocation and dynamic type of memory allocation. Basically, here the concept of a dynamic memory allocation, in which we are talking about some kind of a programming, some kind of a functions that supported by the C language, and basically used to allocate the memory at the runtime, right? So in this lecture, I am only focusing on the malloc function, and we will come to know about the malloc function and how it will work, and how it synthetically work in a C language, right? So let's get started with this topic. The outcome of this lecture, the learner definitely will learn about the malloc function and basic syntax which we follow to implement in the C, and how it can be work with some kind of examples. And next we will talk about the memory representation. That means there is the basic difference when we are allocate memory statically and when we are allocate memory dynamically, and what are the type of representation in a memory it will use, right? And next we will complete this topic by taking an example, and at last we will discuss some application areas where the malloc function is very important and usable in the real scenarios, right? So basically, first of all, we are talking about the malloc function. So in the last session, I will give the brief description about these functions, and here the malloc function is basically used to allocate the memory. So the question is where we are allocate the memory. Basically, this question is fulfilled by the answer. Basically, if I want to allocate memory at the runtime, and as you know, the runtime, we are talking about the execution time, right? So when we are execute a program, when we are implementing, or you can say in a real life, in a real time execution, will implement in a C language, that time allocate some kind of memories, and this memory is nothing but it is a dynamic memory, right? Because dynamic memory tells about how much memory you will use to execute this particular code. And if you have enough memory space, it will execute successfully. If you have not enough space, then the program will एक तरीके से हमारा मेमोरी लैक ऑफ की वजह से टर्मिनेट हो जाता है. तो दिस प्रॉब्लम इज handled by the dynamic memory allocation. So malloc function is used to allocate memory in a C language dynamically, because it will provide the space at the execution time, right? It returns a pointer of type void, and which can be cast into the pointer of any type of data, right? So what is the meaning of this statement? That means whenever we are using the concept of malloc function, it will allocate some kind of space, and this space is assigned to a pointer. And as you know, the pointer initially or by default have the void return type. Yeah, it has a void, right? So basically, when we are implementing malloc function, it will allocate memory space, and this memory space is assigned to a pointer, and pointer have the void return type, right? So here we have to need to typecast into the another type of the return type, right? So it has initialized each block with the default garbage value initially. So basically, if I have I mentioned the size of the particular block, though, then it will allocate that particular space. If I have no mentioned the size, that means the C compiler support a particular garbage value that will initialize the pointer through which memory allocation या malloc function we allocate, right? So malloc function is used to allocate memory block. Memory block, that means here we have a single block of memory that will be assigned to a particular pointer variable at the runtime. How it will implement syntactically? So here we have a we can say that the primarily important lines that we help to work with it. So basically, whenever we are implementing the concept of dynamic memory allocation methods or functions, here we have to need to include that particular library. This library is a stdlib library. That means the all default functions that will be supported by the C language is included in this library. Next, we have a prototype. Prototype is nothing but it is a way of declaring, a way of defining, a way of designing, right? So how we are defining malloc function, right? So way of defining, it will be instructed by the prototype that will be given in the C language. So here we have the return type. Return type is what? Is void. So basically, initially whenever you are using a malloc function, it will initially have the return type void. So next is this is a star, that is a typecasting, and malloc is the function name that will be used in a C language. And next is a int size. Size tells the actual memory block, or you can say the number of blocks that will be assigned through this function, right? So this particular statement is followed whenever we are implementing the malloc function. Next, if I am talking about the real life uses of this function, you can also write in this format. Here we have a ptr. Ptr is nothing but it is a pointer, right? It is a pointer. In the previous section, we will discuss about the pointer. Pointer is nothing but it is a variable that stored the address of another variable, right? In the previous lecture, you can follow this video to understand the concept about the pointer. So ptr is a pointer variable that stored the starting address of the memory. Starting address, that means we are talking about a block of memory, and this particular block of memory is considered as a single block of memory, but it ultimately divided into some kind of blocks. So the first block is considered as the first address of this memory block, because this particular block is the starting address of this memory block. So basically this block of address is contained into the ptr, right? If I am talking about the memory representation or the actual memory allocation procedure in a C language, so basically here we have a concept ki malloc is used to allocate a single block of memory to that particular variable that will considered as a pointer variable, right? So the very first address, the address of the very first block of this memory is stored into the pointer variable, and this address is considered as the starting address, or you can say the base address of this memory block. So next, here we have the, in this line, next term is a ptr type. So ptr type is nothing but it is a typecasting, right? So how it will work, let's see in this explanation, right? So ptr type that tells about the pointer data type. अब this pointer data type may be a integer type, float type, right, char type, or any form. How? Let's see in this. ptr type specify which type of data the pointer will points. So if in this block of memory, in this block, we have the some kind of values or some kind of data, let's say 75, 70, 10, 35 and 14, right? So what is this? This is the data, and this data is stored in this memory block. So PTR type, that means point to the type that the pointer will point, right? It ensures the type safety while accessing the allocated memory space. So basically this type may be an integer. If I am declaring that, in that scenario, that means pointer points to the integer. If I am declaring, yeah, I am using this particular expression, yeah, I am using this type of syntax, that means pointer points to the float value. If I am using this type of implementation, that means pointer points to the character value, right? So why typecasting is needed is this question is arised whenever we are implementing this type of explanation, right? So what is the actual meaning of the typecasting? Malloc returns a void. As you know, Malloc always return a pointer, and this pointer always the type of void, right? And the void cannot directly assigned to other type of the pointers, right? So basically here we have the need to typecast this void pointers to a particular type of the that will represent some kind of values. It may be integer, it may be float, or it may be char. So this type of explanation tells about the typecasting of the pointer variable. So it converts generic void type of pointers into the specific pointer type, and this specific pointer type is that type, right? So basically by using malloc function, this generic void pointer is typecast into integer, float or char. It helps the compiler to understand how many bytes to access when dereferencing. So this is the next question whenever we are implementing the malloc function, ki when we are using, when we are accessing this particular pointer, so how can we do this? So we are doing this by using dereferencing process. How it will work, we will see in a next example, right? So here we are taking an example, very easy example to understand the core concept of the malloc functions. So as you know, Studio is stdio, that means standard input output library used to implement the core concept of the C language like printf and scanf. stdlib, I am telling about whenever we are using C supportive functions, basically for dynamic memory allocation, we are using this library. As you know, the program start with the main function and the return type is integer. We will come on the next topic. Here we are declaring a pointer variable, right? What is this? This is a pointer variable. What is the identification of a pointer variable? So basically it differentiate a normal variable by this particular symbol. This symbol is a asterisk symbol, and this asterisk symbol is specify ki a pointer is a a variable is a pointer variable. Let's say I am declaring a variable a, so this is a normal variable. Are you getting my point? If I am declaring is s, so this is not, but it is a pointer variable. Are you getting my point? So this is the basic difference whenever we are declaring a variable or pointer variable. So always we are using this particular symbol. Next we are taking in a n and I. So these are the variables to define in advance to implement this particular. So in this program we are inputting some kind of values. It may be a n numbers. So let's say 5, 10, 15. Any numbers you can take in a n, because n is varying during the execution time. If I am declaring here n is equal to 10, so this is a fixed. At the runtime, I am only using 10 values. Yeah, I am only storing 10 values, right? Yeah, 10 data. But n here is a variable number that will be decided at the runtime. It may be a 5, it may be a 10, it may be a 15. As per the requirements, you can initialize the n, right? So next we will implementing a malloc function. So this is the malloc function, and what is the syntax? The syntax is the return type, the pointer type. So here pointer type is int, because I am converting the void pointer into the integer type, right? So here I am doing the typecasting of a void, generic void pointers into the integer type, right? So here I am using this particular statement and then malloc function, and that specify the size, right? How many variables you are using into the memory, or how many elements you are taking into a memory, and the size of int. By default, if I am talking about the size of int is considered as a 2 byte. This is also varying in some operating system or compiler. You may see ki here the size of int is considered as a 4 byte. So this is only the case old and new, right? If you are using you are working with the new operating systems, so integer will considered as a 4 byte. If you are working with the old operating systems, so the integer size, or you can say the size of the int variable, is considered 2 bytes. So basically, if I am taking n as a 5, so total number of blocks, total size of memory block is allocated by this malloc function. So basically 5 into 2, that is a 10 byte. If I am using 4 as a integer size, so here we have a 20 bytes. So this is the basic concept through which we are allocating a memory, and this memory is a single block of memory, right? Single block of memory. So here the memory block size is 20 byte. Are you getting my point? So basically, how many elements I am storing in this block? 5. So 1, 2, 3, 4 and 5. So how many block of memory it will be assigned to that pointer variable? So here we have a 5 elements, and the size of each element is 4 byte, and the total space of memory that will occupied by the pointer variable p is 20 byte. Are you getting my point? So this is the concept. Now if I am working with this example, let's say कि हमें ये चेक करना है या हमें वैल्यूज को स्टोर कराना है, तो वी विल फर्स्ट चेक कि आई हैव द इनफ स्पेस टू स्टोर दैट पर्टिकुलर वैल्यू और नॉट. सो फर्स्टली वी विल चेक कि इफ पॉइंटर इक्वल टू नल, लेट्स से कि द इनिशियलाइज्ड और द एलोकेटेड वेरिएबल is not have the enough space to store the next values. So firstly we will check always whenever we are inputting or whenever we are storing new element into that space, we will check कि pointer is equal to null. If pointer is equal to null, that means there is not a available space in the memory, allocated memory space. Let's say I'm very initially I am storing 1, then I am storing 2, then I am storing 3, then I am storing 4, and then I am storing 5. Next, I want to insert another element into that memory. So firstly, I will check if memory have the enough space to store the new element. If space is available, that it will allocate the space in this manner. If space is not allocated, so there will be instruct by the program. So what is the instruction will followed? The memory is not available to storing that particular variable. So this is the concept. If memory is available, then we will go with this process. So here we are applying a for loop. As you know, for loop is applying whenever we are repeating something into the same manner. So basically I am repeating here to storing a value. So basically printf enter the value and scanf, that means p plus I. So very initially p is nothing but it is pointing a starting variable, starting block of the memory. So what is the address of the starting block of memory is a ptr, that is a 0. So I am putting the value ptr, that is at 0, right? So let's say I am storing value 10. Next it will increment by this statement. I will become, let's say I plus 1, that is 1. 1 is less than n, condition true. Let's say n is a 5, condition true. True, that means go down and execute the further instructions. So what is the further instruction is a enter the value, and where we are entering the value, now p is become p plus I. So what is the I is here 1, and what is the p is here 0. So 0 plus 1 is 1. So now pointer is coming on that block of memory, right? So now we will input 20 value, right? So in this process we are implementing the same scenario till we have enough space to store the next value. At last we are printing this particular, we are accessing these values from the memory. How can we do this? We are using a dereferencing. In the last slide we are talking about the dereferencing process. So what is this dereferencing process? Is to access the value from the memory, right? So how we are doing by using a asterisk symbol, because this asterisk symbol specify the dereferencing of the pointer. If I am talking about the address of the pointer, so basically refers to the ptr value. If I am talking about the value of the pointer variable, that we will use to dereference it, right? So for dereferencing we are using simply star symbol, right? So this always provide a value and this always provide the address of the block, right? So this is the concept. How can we represent memory? How can we calculate the size of the total size of the memory that will be allocated by the malloc function? So here I am showing the accurate calculation through which we are calculate the total size that will be provided by malloc function, right? So let's take the simple example. Like we have a variable that is a roll number and size is 6, right? Here we have the pointer variable ptr, and now we are allocating memory dynamically by using the malloc function. This is the typecasting, this is the size of the memory that we want to allocate. So this ptr variable is allocate a particular space, and this space is considered as a single memory space, and this space is divided into it will contain the 6 byte, because here we have the total number of elements is 6, because roll number size is 6. Next we will talk about the application uses of the malloc function. So basically the malloc function is most widely used to implement the dynamic memory allocation, because it provides the enough space at the runtime or execution time whenever whichever I want to required, right? So next it will always it most widely used in creating a dynamic arrays. If I am talking about the array implementation, in which we have a drawback, it will considered as a static type of initialization, because in advance we have to mention the size of the array. In a C language, just for example, I am declaring an array like this, right? So this syntax is not supported by the C language. So for this purpose, we have to mention the size of the array in advance, right? So this this particular scenario is fulfilled by the dynamic memory allocation function, basically by using malloc function. Next, the uses area of a malloc function is efficient memory utilization. Why efficient memory utilization? Because if I have the requirement of 5 block of memory at that time, so basically I am doing this particular situation according to the situation, but at the same time I have the requirement of a 20 bytes for the same implementation, so I can extend the size of the memory by using dynamic memory allocation function, or you can say the malloc function, right? And next, implementation of the data structures. So basically array is malloc function is most importantly used to implement the another data structure in which we are talking about the some kind of arrays, stack, list, linked list, or queues, and etc., right? So all the advanced data structure are implementing by using malloc function. It also helps to handle the large data. If I'm talking about the heap memory, because heap memory have a large space and it will utilize at the execution time. So basically it most widely used for doing this. This is the today's lecture, and this lecture is more beneficial for the MCA student, MCA first year student. So with this, I'm done with. Thank you.